Alright, so these examples were specifically chosen because they all have something in common, which is that they both have variables on both sides of the equal sign. And this is something we haven't seen before. And so just like with the balance scales you saw on the previous slides, what we're going to try to do here is we're going to try to incorporate this into our process so far. And so what it looks like is something like this. Step one has not changed. That before you ever get into the solving of the equations, that the first thing we want to do is to simplify things, to make it a little bit cleaner and neater to work with. So if you see parentheses where some distributive property could be done, we want to clean that up. If there's any like terms that we can combine, either on the left or the right, we do that first. All right, then here's the part we're adding in today. Is that what's confusing about this equation compared to all the others we've done so far is the fact that we've got variables on both sides of the equation. And so our job in step two is to separate the variables to one side of the equation or the other. And it doesn't matter which one. You just want to do whichever is easier. And then finally step three, which is something we've been working on for the past 3-4 days, which is to actually solve by doing opposites and then to incorporate this idea of the roadmap where we do things in the opposite order. All right, so let's take a look. Let's apply all those steps. So step one is simplify. Well, I don't see any parentheses to do distributive property. And these like terms are on opposite sides of the equation. I can't just move them. So step one, there's nothing to be done. All right, so now step two is separate the variables to one side. All right, so I think what I'm going to do here is the way I'm going to separate those out is I'm going to get rid of this 2x. That way, I've got variables on one side and my numbers on the other. Okay, now, remember, you're not trying to just get rid of the 2 here. We're trying to get rid of the entire 2x. So they've added 2x. We're going to do its opposite. Subtract 2x, subtract 2x. Okay, these will cancel out. And we accomplished what I wanted in step 2, which is now I've got all the variables separated to one side. I've got negative 5x on the left side equals 19 on the right side. All right, now in this case, I could do the roadmap, but really there's only one step. Here they've got x times by a negative 5, so we're going to do its opposite, which is to divide by negative 5, divide by negative 5. These cancel, leaves me with x, and this isn't reducible, so I'm just going to leave this as 19/5. Okay, but the key element here is what we did here. This is the new step. This idea that anytime you see variables on both sides of the equation, you need to get rid of one of them to make it look more like the work we've been doing. Now, the question that usually comes up here is, well, why did I pick the 2x? Okay, and this is something you'll start to see as you get better at this. Let's say I take the same problem. Watch what happens if I had done the other thing, which was to move to get rid of this negative or minus 3x. So that work would have looked something like this. I would have checked to see if I could simplify it, which I can't. I then would have added 3x to both sides. These cancel out. Now in this case, I just can't leave the left side blank, so I'm going to leave a filler 0 in. 5x plus 19. Okay, so now my roadmap would look something like this. I've got x, which has been multiplied by 5 and added 19. So I'm going to pull my U-turn and do the reverse moves in the reverse order, which is to subtract 19 from both sides. And then divide by 5. And I get x equals negative 19/5, just like before. But if you take a look at the work, notice how this one is a little bit longer. I had to do one step more here than I did here. And so hopefully you'll start to get an eye for this, that, you know, if you do it this way, no big deal, but you have made extra work for yourself. And the way I came to the decision of doing it this way is, well, I realized that at some point in the process of solving an equation, I want to not only get my variables to one side of the equation, like step 2 says, but I eventually want all the numbers on the other side. So when I was looking at this, I figured, well, you know what? My numbers are already on the right. So a smart move would be to get all my variables over to the left. So that's what made me pick this 2x to get rid of, because it saved me a step in the process. Here, I didn't use that logic, and it just took an extra step. Still got the same answer, but if you can start to see the reasoning behind that, it'll save you some time and effort.